Hello, a great welcome to this presentation. Myself, Jarajan P. I am happy that finally we were able to launch this series on the design of machine foundations. This series would have approximately 20 to 25 numbers of videos. So, obviously, this is the first video of the series, and this is titled Introduction. So, before getting into the details, let me just help you to provide a list of reference textbooks that would really help you to improve your knowledge on the subject. Okay, as you can see that I have listed around four important documents. The first one is Foundations for Industrial Machines, Handbook for Practicing Engineers by Dr. K.G. Bhatia. And let me just tell you that this is one of the most important resource that I have used for this presentation. And the beauty of this book is that this is written by an author who has got an extensive experience in the industry in the field of machine foundations. And the second one is a very important book on structural dynamics, also for the vibrating machines, that is Design of Structures and Foundations for Vibrating Machines by Suresh C. Arya, Michael W. O'Neill, and George Pincus. Then I have listed some documents under number 3 and 4. These are essentially not books, but in these documents, each chapter is contributed by a subject specialist, and accordingly, it is a little bit different, and you will find some of the chapters very, very useful, and they stand outstanding compared to the textbooks. So, the first one of such a book is Analysis and Design of Foundations for Vibrations, edited by P.J. Murray, and the last one is Analysis of Pile Foundations Subjected to Static and Dynamic Loading, edited by Amir M. Kainia. So I would also provide you a list of BAS, that is the Bureau of Indian Standards, that is on the design of machine foundations. I am very sure that you must have gone through these documents if you were designing the machine foundations. And the basic document is IS 2974, and that is furnished under 5 parts: Part 1, Part 2, 3, 4, and 5. And each part covers a particular type of machines. So for example, part 1, as you can see, that it covers the foundations for reciprocating type machines. And part 2, that is covering impact type machines, essentially hammer foundations. And the part 3 is for foundations of rotary type machines with the speed in the medium to high range. And then the part 4 is for rotary type machines again of low frequency, that is the low speed. And finally, part 5 is on hammer foundations. But these cover impact machines other than the hammer. Okay, now let me take you to the basic definition of a machine foundation. As you can see that machine foundation consists of two terms. One is a machine and the other one is a foundation, and that constitute its definition. So here I have again a machine foundation. It consists of a machine that is supported on a suitable type of foundation, transmitting both the static and dynamic loads to the surrounding soil. So you can see from this definition what makes a machine foundation unique. It needs to transmit the dynamic loads also in addition to the static load to the surrounding soil. And how the machine is supported to the foundation? The machine can be either directly connected to the foundation through a set of bolts, or it can be connected through isolation devices. And based on the foundation analysis requirements, the foundation, that is the machine foundation, it can be supported either directly on soil or on the pile. For example, here I have shown a what I call as a frame type machine foundation that supports a turbo generator. As you can see that this is the turbo generator, and you'll find that there are too many pipings, connections, etc. It's a very complicated machine, and this is supported directly over an RCC deck slab, and that is connected to the base raft through a number of columns. We will get into the details later on. Now, we need to know what is the basic philosophy that need to be followed in the design of machine foundations. For example, if it is a foundation that is supporting the a building foundation, for example, we know the requirement to be satisfied is just that the actual pressure on the soil should be less than the bearing pressure without any excessive settlement or differential settlements. For machine foundations, we need to respect some additional criteria as well. So let me just start reading it. So the first one is transmitting all dynamic and static loads safely to the surrounding soil. Obviously, safely means the bearing pressure should not be exceeded. And remember, in addition to the static loads, we have a dynamic load also. And the second one is the most important one, and that is the focal point of all our machine foundation analysis. That is to keep the amplitude of vibration of foundations within the specified limits to ensure smooth running of machine. So here we mean the machine foundation shall be designed to ensure smooth running of machine. This is an important and a primary requirement. And finally, the foundation, as usual, must be structurally safe to withstand all static and the corresponding equivalent dynamic loads generated by the machine. Now, let us get into some classification, basic classification of machines. We will get into the details of the machines later in our series. So this is, as it is just an introductory part, I would like to give you some brief explanation on the machines as well. Now, machines can be classified broadly on two types of parameters. First one is the type of motion they generate during their operation. For example, we have a rotary machines. As the term suggests, you know that here the machines essentially generate a rotary motion or a rotation around the axis. Then we have the reciprocating machines, wherein the motion is essentially a repetitive back and forth linear motion. And in some cases, instead of back and forth, it can be up and down as well. Then we have an impact type machines. And basically, these machines produce the impact loads. So remember, this classification is strictly based on the type of motions these machines generate during their operation. Now, next one is the classification of machines based on the operating speed. So here we have very low speed machines. For example, we can have a machine of up to 100 RPM. Then we have low speed machines, that is from 100 to 1500 RPM. Then we have medium speed machines 1500 to 3000 RPM and high speed machines 3000 RPM and above. So let us just now discuss the foundation types that are broadly used in practice to support different type of machines. So first I would like to tell you that the selection of a particular machine foundation, it is essentially governed by the machine type and its characteristics. That is very important. So you please note that it is the machine type and its dynamic characteristics that decides the type of foundation. It is broadly nothing to do with the soil type or any other parameter. So the first one is the most simple foundation type, the block foundation. So as the name suggests, you can say that the foundation essentially consists of a block of concrete, and the machine is mounted over a solid block of concrete, and you can have multiple smaller pedestals that directly anchors or directly supports the different machine components. And this block foundation can be supported directly over the soil, or you can take it through the piles. Then the next one is the frame foundation. So as the name suggests, the foundation consists of a set of frames. You know what a frame is. And as you can see that here is a sketch of a frame foundation. So here what is done is the machine is directly supported over a deck slab, and this deck slab normally in my experience could be of the thickness of 1 to 1.5 meters, so thick. Okay, and it can have a multiple number of openings that allows you to take the pipings connected to the instruments to the other parts of the plant. And so this deck slab is connected to the base raft through a number of columns. So basically the load transfer mechanism is a frame action, and the base raft, just like the block foundation, can be directly supported over the soil, or you can use the piles as the foundation forms to support the loads. Then we have the box type foundation. So it is very clear to you, it's a box type, so it forms a box. So here what is done is that the machine is directly supported over a solid slab. Okay, and this solid slab, it is connected to the base raft through a number of vertical standing walls. And the base raft again can be directly bearing against the soil or through the piles. The next one is the wall type foundation. So the wall type foundation essentially consists of a series of walls of different dimensions that directly supports the machine to the base raft. Okay, and the base raft again, it can directly support on the soil or through the piles. So for example, here you can see that there are two main walls, okay, that essentially provides the main support to the machines, and there are also two smaller walls that supports other components of the wall. So in general, we have around 4 types of foundations, and remember, the choice of any foundation type, it is solely governed by a single factor, namely the characteristics of the machine. So finally, you will ask me a question: what makes the analysis of machine foundations a challenging task? And this is a question which I should answer, because it lists a number of factors on which you should focus. And if and only if you focus on these important characteristics, then you will be a good machine foundation designer. So let me take you to the different points. The first one, the analysis of foundations for machines is a challenging task, considering that any malfunctioning of these machines arising out of excessive vibration of the foundations would affect the overall performance of the plant and even cause shutting down of the plant, causing millions of dollars of loss to the owner. So this is a very, very critical aspect. Please remember, the machine foundation is just a part of a big process unit. Maybe that it is a part of a refinery or a petrochemical complex or a power plant. So if during the operations the foundation vibrates excessively, the only choice is left is to shut down the machine. So shutting down the machine means it will have a very big impact on the production, causing millions of dollars of loss to the owner. So this is one of the important fact that we should keep in focus. That means there must be a very good focus on the safety and also the performance of the foundations in order to ensure that the entire plant runs smoothly. Okay, so here note down, excessive vibration on the foundations, it would affect the overall performance of the plant. So the machine foundation is not a standalone entity, it is connected to, it is just a part of the plant. Next one, in addition to static loads, the machines also transfer dynamic loads or moments at specific frequencies to the supporting foundation. This dictates that a detailed vibration analysis is performed to ensure that the acceptance criteria, frequency ratio, and amplitude provided by the machine manufacturer are met. So this is another important fact to be addressed. That is, in the case of the conventional foundations, we need to perform just a static check to ensure that the foundation, the pressure which the foundation transfers to the ground is less than the soil bearing strength, and that the resulting settlements, whether it's a total or the differential, are within the limits. But in this case, in addition to the static checks, you need to perform a detailed vibration analysis. And I will tell you that for a machine foundation designer, this will be consuming almost 90% of his time. So a detailed vibration analysis. Why a vibration analysis is required? In order to ensure that The natural frequency of the machine foundation soil system, it is nowhere near to the operating speed of the machine. And further, we need to ensure that the amplitude of the foundation or any critical part of the machine during its operation is within the limits that is provided by the machine manufacturer. So ensure that the requirements will be set very specifically in the detailed drawings that is provided by the machine manufacturer. So this is the second point. So in the second point, focus on detailed vibration analysis. So the third one, the engineer in charge of machine foundation design shall be familiar with the basic concepts in both structural and soil dynamics. The engineer also needs to have interdisciplinary understanding about the mechanical and electrical components of the machine to enable a better reading of machine manufacturers' drawings. This is an area where many engineers lack, because as I clearly specified in point number 2, you need to perform a detailed vibration analysis. This means that the design engineer need to have a basic understanding in the field of structural and soil dynamics. I don't say that they need to be experts. It's well and good if they're experts, but they need to have basic concepts and or a basic knowledge in both structural and soil dynamics. Why in soil dynamics? Because we know that the foundations are supported directly by the soil. So the dynamic characteristics of the soils are to be properly read out, and that should be used in conjunction with the foundations. Or in other words, we are going to analyze a system that is essentially consisting of three components. One is the machine, second is the foundation, and finally the soil. So for the foundation and the superstructure, please have a basic concept in the structural dynamics, and for the modeling the soil, you need to have basic concepts in the soil dynamics. And another important thing is, see, the basic input for any engineer who is performing a machine foundation design is a set of input drawings, and these input drawings are specifically provided by the machine manufacturer. So you must be able to read it very clearly and extract the required information. Maybe that it is okay having thousands of informations inputs, and maybe say 80% of it is not required for your end. So it does mean that the engineer must be able to pick up the correct input directly from the machine manufacturer's drawings, and in case any important data is missing, it is the responsibility of the design engineers to write to the machine manufacturer and get the required input before proceeding to the other part of the design. And in many cases, there are also instances where the design engineers read a machine manufacturer's input incorrectly. So in case of any doubt or any clarification required, it is very critical that you write a message to the machine manufacturer regarding your understanding of the input data and your interpretation, and get the correctness of your interpretation from the machine manufacturer. So means you need to have the basic concepts in the structure dynamics, soil dynamics, plus you must be capable of reading a drawing that is provided by a machine manufacturer, which essentially consists of the mechanical and electrical components. And finally, the engineers shall have expertise. I don't say that expertise, but even a good understanding of the use of the FEA tools is good enough. That would help in the proper modeling of machine foundation system, and thereby to arrive at reliable results. So here I would like to tell you that maybe for a simple foundation, you can use the hand calculations. But for many of, I would just tell my experience, I've used almost 90% cases the FEA tools. For example, we have used the Abacus, we have used the ANSYS, we have used the SAP 2000, okay, for the FEA modeling of this machine foundations. So you need to have an expertise in the FEA tools, and this will also help you for a better time management of the project, and also to help you to get a reliable outputs. And for a better interpretation of these results, you need to have a better understanding of the tool as such. For example, if you are using the ANSYS and if you are using the Abacus, you need to have a better, a lot more skills compared to the SAP 2000. So I think that here I have introduced you the very basics regarding the definition of the machine foundations, the basic Indian standards, the definition of the machine categories and the foundation types, and also what makes the machine foundations a challenging task. So I think that's all for this first video in this series. So thank you for listening.